Here is our warm-up for today, practicing what we learned yesterday. For number one, I'm going to show you how you could do this problem two ways, and then that should hopefully clear up how you can do the different methods from yesterday on the same problem. If you noticed that 8 and 32 can both turn into a base of 2, we can change 8 into 2 to the third, but then keep in mind it already had a 2x, and 32 we can change to 2 to the fifth. So then we would multiply these exponents together to get 6x is equal to 5, and divide both by 6. So x equals 5 over 6, because again, you do not need to change it to a decimal. Now let's say you didn't notice that they had the same base, and you introduced a log into both sides. So if you did that, you would have log 8 of 2x is equal to log of 32. We would then take this exponent and move it out front. So it'd be 2x log 8 equals log 32. Divide both sides by log 8. So if you have log 32 and divide it by log 8, you get 2x is equal to 1.6 repeating. And then in your calculator, you would then go divide by 2. And x would equal 0.83 repeating. If you typed in 5 divided by 6, you also got 0.83 repeating. So both methods do work. If you don't want to try to change them to the same base, then you can add a log into each problem. Now going back up to number 2, here there is no way to turn an 8 and a 3 into the same base. So we're going to introduce the log. So log 8 to the n plus 1 equals log 3. Move that exponent out to the front, and I'm going to put in parentheses. Divide both sides by log 8. So I have n plus 1 equals, and log 3 divided by log 8 is 0.5283. Again, just keep it in your calculator and then go minus 1. And we'll round it to the nearest 10 thousandths. So n equals 0.471. It was a 6, but the number behind it's a 7, which tells us to round up. So 7, and it should be a negative. So again, there are two methods to solve these equations. If you don't want to worry about two methods and you just want to go with one method, then you could simply insert logs to each side. Homework answers from last night. Number 48, they turned it into the same base for you, and then you just had to set your exponents equal to each other to solve. 49, they also found the same basis for you. 50, you had to find the same base. 51, 52, and 53, we're taking the logs. Pay attention to 53. You have to get rid of this minus 24 before you can do that. You need to isolate the number with the exponent. And directions were to round it to the nearest 10 thousandths, which is what we did for a warm-up as well. So go ahead, check through the answers on here in the work. Talk it over with a classmate if you need to. And then we're going to be moving on to the second part to 4-5 today. Make sure you have the page of notes in front of you. Today, the one thing we're going to have to pay special attention to is when we find the solution, to the logarithmic equation, we need to check our answers. So yesterday we inserted logs into the equations. Today we're going to have logs already in the equation, which is why we're going to have to check your answers. So a couple rules here. First is we cannot take the log of a negative number. Should be why you haven't seen negative numbers. The answer can be negative, but you can't have log of negative 2.5. That's not allowed. And you cannot take the log of 0. Now there are two kinds of problems we're going to run into. The first is when we're going to solve with a log on just one side of the equation. And when that happens, we're going to turn it into exponential form. And then solve for the variable. So logs and exponential forms are kind of like inverses of each other. So if it starts off as exponential, like yesterday, we insert logs. If it starts off with logs, then we convert it to exponential form. So our first example here says log of 2x equals 3. Now, remember, when there's not a base number, we know it's a base of 10. So it's 10 to the third, because the exponent's always in the equal part, and that's equal to 2x. Well, 10 to the third, if you know it, that's great. If you don't, then you would go 10 exponent key 3, or 10 times 10 times 10, which is 1,000. We would then divide by 2. So x equals 500. Now we have to check this. So this one's going to be easy to check because it's a base of 10 already. So we're going to go log of 2 times x, so 2 times 500, and we want it to equal 3. Well, 2 times 500 is 1,000. So in your calculator, you're going to go log of 1,000 or 1,000 log, and you should get 3 equals 3. And there's our check. So x equals 500 is the answer. If you had gotten a check that wasn't true, like 3 equals 5 or something like that, then there would be no answer for this problem. 500 would be like a false answer. So now go ahead and try the U-try on the right. Notice this time it does have a different base number, so you're going to have to apply your change of base rules as well. Work through it with a neighbor if needed, check your answers, and then unpause the video when you're ready to check it together. So here we go on the U-try. The first thing is we need to convert it to exponential form. So 6 is your base, 2 is the exponent, equals 3x. 6 squared is 36. Divide by 3. You should have gotten an answer of x equals 12. To check that, we now go log base 6 of 3 times 12, and I want to know if that's equal to 2. Well, 3 times 12 is 36. To figure out what log 6 of 36 is, again, we're going to use our change of base. So log 36 divided by log of the base, which is 6. And I want to know if that's 2. So 36 log divided by 6 log, or log 36 divided by log of 6, depending on how you type it into your calculator, and you should get 2 equals 2. So again, we do have an answer. Going to the next one. Log 4 of 4x minus 3 equals 3. So we have a bigger equation that we're going to be solving here. So first thing is we write it in exponential form. So 4 to the third equals 4x minus 3, because remember, it's your base to the exponent. Well, 4 to the third is 64. Add 3 to both sides. 67 is equal to 4x. Divide by 4. So x is equal to 16.75. So now we're going to check it. So log base 4 of 4 times 16.75 minus 3 equals 3. So we'll start simplifying the inside. So log base 4, 4 times 16.75, that's 67, minus 3, and again we want that to equal 3 at the end. 67 minus 3, well that's 4. Since we don't have a base of 10, we need to use our change of base formula. So log 64 divided by log of 4. And when you type that into your calculator, you should get that 3 equals 3, which means 16.75 is a legitimate answer. So now go back and try the next problem that you try. Check with your neighbors as you get through it, and then unpause it when you're ready to officially check. So the first thing we're going to do here is change it to exponential form. This one, the base is not listed, which means it's a 10. So we have 10 to the negative 1 equals 3 minus 2x. 10 to the negative 1, you can type that into your calculator, and you get 0.1. The 3 is positive, it's the 2x that's negative, so since the 3 is positive, we subtract. 0.1 minus 3 should have given you negative 2.9 equals negative 2x. Divide by negative 2, and you get 1.45. You still had to check it, so we go log of 3 minus 2 times 1.45 for x. Simplifying inside, 2.145 should be 2.9. Three minus 2.9 should be 0.1. Since this one is a base of 10, we can just type that directly into your calculator, and when you type in the log of 0.1, you should have gotten negative 1, which is what we also had on the right side. If you use the change of base form, then it'd be log of 0.1 divided by log of 10, and that would still give you negative 1. So that was another legitimate answer. Now, what happens when there's not just one log on a side? There's more than one. Well, the first thing you're going to do is you're going to combine it to one single log. So if the logs are being added, that means we can multiply the pieces. If they're being subtracted, we can divide. All of those rules that we learned earlier. And then we're going to convert to exponential form. And then, of course, solve for the variable. So in our first example, we have two logs with the same base that are being added. Well, when we add two logs, that means we can multiply to put them together. So we've got log base 6 of y squared times 2 cubed. That's going to equal 2. Well, I know that 2 cubed is 8. And when we've got a number and a variable, the number comes first. So this becomes 8y squared. So now we change it into exponential form. So we go base, which is 6 squared for this over here, equals 8y squared. Well, 6 squared is 36. To start solving for y, we're going to divide by 8, which is 4.5. And the opposite of squaring something is to take the square root. Now, if you take the square root of 4.5, you're going to get a continuing decimal. So we're just going to round it to the 100th. So y is approximately 2.12. And again, problems like this, the directions would tell you where to round to. Now we're going to start the u-try together just to make sure we don't make any mistakes here. They're being added, which means, hopefully remember, you're going to multiply the pieces, but before you do that, you've got to move these numbers on the outside. And remember, numbers that are on the outside can turn into exponents. So that's going to become x squared and 2 to the 4th. So go ahead and work on this problem, and then unpause it when you are ready to check. So as you rewrote this, so we have log of x squared plus log of 2 to the 4th. Adding means we're going to be multiplying. And when I multiplied the 2 to the 4th times x squared, 2 to the 4th was 16. So times x squared equals 3. Now I can put this into exponential form. There's no base, which means we have the base of 10. Exponent is 3. 10 cubed is 1,000. Divide both sides by 16. So x squared now equals 62.5. Again, the opposite of squaring something is to take the square root. And that should have given you approximately 7.91. Last type of problem here is when you don't just have a log on one side, you have it on both. Well, first thing to make sure is that on each side there's only a single log. If the logs have the same base, you're going to set the arguments. Now the argument is, for example, if you have log base 5, and we'll just go with that x minus 6. This is considered the argument, the piece of the log. So as long as you have the logs on both sides that are the same, you just simply have to set each of their arguments equal and then solve for the variable. So if I look at the first example, I've got one log on this side and one log on that side. That's the first thing to check. The second thing is they both have the same base. So I can get rid of the logs and I simply have x minus 6 equals 7. Solve for x. So we would add 6. So x equals 13. So go ahead and try the next U-try problem. So here again, the two things you should have looked for is there's 1 log on this side, only 1 on this side, so that part's good. Both logs have a base of 2, so I can cross the logs out, and I'm left with x plus 8 equals 14. Subtract 8, so you should have gotten x equals 6. Last two examples here. So again, we have logs on both sides. So the first thing to check is that there's only 1 log here and only 1 log here. If not, you would combine them into your single logs, just like we did on the first set of examples. So then I check and make sure the bases match. Both of these have a base of 10 since it's not listed. So I can cross out the logs, and I have x squared minus x equals 6. Now this one's different because not only do I have an x squared, I also have an x. Well, when that happens, we have to make sure one side of the equation is equal to 0. This is a problem we did a while ago. Everything comes back in algebra. So I have x squared minus x. Make that a little bit neater. Minus 6 equals 0. To solve this, hopefully you're recognizing that this is a factoring problem, which means we're going to use the Santa hat here. So we've got 1 for the x squared times negative 6 so we're looking for factors of negative 6 that add to our middle term, which is a negative 1. So take a second and try to remember what those factors would be. Hopefully you thought of the pair negative 3 and positive 2. So because this is this easy factoring because the coefficient's 1, we can go directly to x minus 3 and x plus 2. And now we set both of them equal to 0 and solve. Or hopefully you remembered that really and truly the answers just become the opposite. And there are your two answers. So even with logs, factoring can come back into play. So go ahead and work on the U-try, and then unpause the video when everyone's ready to check it. So here we go. First again, only 1 log on each side, so that part's good. The logs have the same base, so we can cross them out, and we have x squared plus 4x is equal to 5. Since I have an x squared and an x, we need one side to equal 0, so we're going to subtract that 5. And then we need our Santa hat. So we have factors of negative 5, and it has to add up to a positive 4. So your factors should have been 5 and negative 1. So we have x plus 5 and x minus 1. If you needed to, set them both equal to 0. If you went ahead and just put their opposites, that's fine. So you should have had negative 5 and positive 1. So several different methods on solving logs here. So you'll want to make sure that as you do your homework, you keep your notes out so you can follow your different strategies.